Hello and welcome to another session of Permutations and Combinations. My name is Prathamesh and we'll be continuing our discussion on permutations and combinations. So let's start the session. Okay, so in the last lecture, we looked at the two fundamental principles of counting on which this entire chapter is going to be based. And we also looked at the difference between these two principles and where to use each of these principles along with 6 examples. Now, continuing the discussion, if you recall, I had taken a few specific examples. I had taken a few specific examples, and the result of those examples, the solution of those problems, was a very a commonly used result. So one of those problems was how many 10-digit numbers can be formed without repeating the digits, any digit. Now, just to recall, I'll give the solution once again. For 10 digit number, so these are the 10 places that we have to fill. Now, because repetition is not allowed, the first place I can fill in 10 ways. I've used up one digit, so the second place I can fill in 9, the third in 8, fourth in 7, 6, 5, 4, 3, 2, 1. And because I'm doing all of these tasks of filling all of these places together, I use the multiplication principle, and the solution is 10 into 9 into 8 into 7 into 6 multiplied all the way up to 1. Let me highlight this in green. Another problem was the word space. I had given the problem the word space. How many anagrams of this word can we form? That is, in how many ways can we arrange the letters of this word to form a new word, provided again repetition is not allowed. Provided repetition is not allowed. So again, 5 spaces because there's 5 letters. The first space, the first place, I can fill in 5 ways, any of these letters. The second in 4, 3, 2, 1. So again, using the multiplication principle, the total number of ways to arrange is 5 into 4 into 3 into 2 into 1, which is 120. So this is one example. Here's another example. How many arrangements exist of seating 6 different people in 6 positions? Now I think you can tell the answer, but because just to make it clear, I'll still give the solution. 6 places, 6 different people. So if I've allotted one person, the first place can be allotted in 6 ways, the second in 5, third and fourth, so on, and you get the idea. So this is 6 into 5 into 4 into 3 into 2 into 1, which is 720. Okay, so in all of these problems you will notice that we have arranged a certain a certain number of distinct objects in the same number of places as how many of those objects there are. That is, we have arranged n distinct objects. Here it's 10, here it's 5. Perhaps I should write in a different color. 5. And here it's 6. In the first case, I've arranged 10 different objects, that is the 10 different digits in 10 places. In the second question, I've arranged 5 letters in 5 places. And in the third question, I have arranged 6 people in 6 places, in 6 different places. So this gives us a common pattern. So excuse me. This gives us a common pattern that the number of ways of arranging n objects, n distinct objects. Distinct, you can interpret distinct as also as repetition of the objects is not allowed. The number of ways of arranging n distinct objects in n places is equal to n into n minus 1 into n minus 2 into n minus 3 multiplied all the way up to 1. This you can see by the examples that we've done. So if there's n places, the first place I can fill in n ways, the second in n minus 1, the third in n minus 2, and so on, all the way till 1, till the last place is remaining. Now this result for any number, if the number is n, this number is known as the factorial of n. Is denoted as n with an exclamation mark. This is definition of n factorial. So this result n factorial, this was formulated for, in fact, the field of combinatorics, and it's also sometimes used in number theory, and sometimes even in the fields like statistical physics and so on. But obviously we'll be sticking purely to the basics of the factorial in permutations and combinations. Now the factorial has certain properties because of the way it is defined, and it helps to know these properties before going ahead. So let me just list down all of these properties. Properties of n factorial. One is obviously its definition. N factorial is n into n minus 1 into n minus 2 multiplied all the way up to 1. Now we can also write this as n into bracket n minus 1 n minus 2 multiplied all the way up to 1, and this number n minus 1 into n minus 2 up till 1, this is just the factorial of n minus 1. So this can be written as n into n minus 1 factorial. Or another way of writing this is n into n minus 1 into square bracket n minus 2 n minus 3 multiplied all the way up till 1. And hence we can also write this as n into n minus 1 into n minus 2 factorial. Now you can see a pattern that we can also write this as n minus 1 n minus 1 n minus 2 into n minus 3 factorial, right? And you can extend this to any length that you want. 2. the factorial of 0 is in fact 1. Now this result can be seen from the pattern that factorials follow. So if you compute the factorial of 1, that's just 1. 2 factorial is 2 times 1, 2. 3 factorial is 3 times 2 times 1 equal to 6. In fact, perhaps you should remember a few of the factorials from 1 up till around 6 to 7. It may help. In fact, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, right? 7 factorial is 5040. Now 6 factorial is equal to what? 6 into 5 into 4 all the way up till 1, right? Which is also equal to 7 by 7 into 6 into 5 into 4 till 1. Now the numerator, if you observe, that is 7 into 6 into 5 into 4 till 1, and that's just 7 factorial by 7, right? So 6 factorial is 7 factorial by 7. So what do you think 5 factorial should be? It'll just be 6 factorial by 6, right? Similarly, 4 factorial will be 5 factorial by 5. 3 factorial will be 4 factorial by 4, so on. 1 factorial will be 2 factorial by 2, and hence 0 factorial will be 1 factorial by 1, and that is why we say that 0 factorial is 1. This is a nice way to remember it. Now few important properties is that factorial as an operation is not commutative or associative. That is m plus n factorial, m plus minus actually. You can either add m plus n or m minus n. This is not equal to m factorial plus minus n factorial, right? And the same goes for m divided by or multiplied by n. This is not equal to m factorial multiplied or divided by n factorial. These are very important properties to know. However, it is worthwhile to note that m plus n factorial divides both, or basically is divisible by both m and n factorial. In other words, we can write m plus n factorial by m factorial n factorial is equal to an integer. This will always be an integer. In fact, this formula, this is an important formula. We will derive this result in a while. So knowing that this fact is helpful. So these are some basic properties of factorials, and let's take a few questions which involve some simple mathematical manipulations with factorials, so that it becomes easier to work with them as we move along and solve for actual permutations and combinations. So okay, so the first is just simple evaluation of terms involving or expressions involving factorials. So say evaluate 1 10 factorial, 10 factorial minus 6 factorial, 10 minus 6 factorial, and 9 factorial by 3 factorial 6 factorial. Now all of these values you can plug in your calculator and calculate. So 10 factorial can simply be calculated by hand as well. But if you calculate 10 factorial minus 6 factorial and 10 minus 6 factorial, which is just 4 factorial, you will come to know the difference between these values. Obviously this value is going to be, the answer to this is going to be much larger than this, right? So that is the property that we wrote here. You can verify the property using these questions. So you can pause the video, compute the factorial for yourself and check. So 10 factorial minus 6 factorial is 3628000. 10 minus 6 factorial is just 4 factorial, that's 24. And 9 factorial by 3 factorial 6 factorial is can write this as 5047 factorial because just because I remember the value, into 8 into 9 by 6 into 720. So this is equal to 720. So 8 into 8 into 9 by 6. So 72 by 6, 12 into 8, 96. A slightly different question. Write the expression 5 into 6 into 7 into 8 all the way up till 10 in terms of factorials. So obviously you can see that this can be the formula of 10 factorial, but some of the first terms are missing. So what terms are missing? If we multiply this by 4 factorial and divide by 4 factorial in order to retain the whole expression, right, this becomes 4 factorial into 5, 6, 7, 8, 9, 10, and that is 10 factorial, because 4 factorial is 1 into 2 into 3 into 4. If you put all those numbers together, it's the numerator is the factorial of 10. So 10 factorial by 4 factorial. Now involving a few more problems about algebraic manipulation. So find n if n plus 1 factorial equals 42 into n minus 1 factorial. Okay, so using the property which we defined before, we can write this as n plus 1 into n minus 1 factorial. N plus 1 minus 1 is n plus 1 minus 2 is n minus 1. So we can write this as n minus 1 factorial into n plus 1 equal to 42 into n minus 1 factorial. Cancelling this term, this is n square plus n equals 42. So n can be 6. There's another root to the equation, but the other root is negative, and n cannot be negative in these examples, so n is 6. Simply highlighting all the solutions. Okay, perhaps I should also solve this problem. So n square plus n minus 42 equals 0, right? Which I can write as n square plus n minus 6n minus 42. Now I've taken 7 and 6 because 7 minus 6, 7n minus 6n is n, and 7 times 6 is 42. So I can write this as n into n plus 7 minus 6 into n plus 7, or n minus 6 into n plus 7 equals 0, implying that n is 6 or n is minus 7. And we're ignoring the negative root of this equation, so n is 6. Two last questions. 6. Show that 2n factorial by n factorial equals 2 power n into 2n minus 1 into 2n minus 3 into 5 into 3 into 1. So basically, what we are trying to prove is 2n factorial by n factorial equals 2 power n into all the odd terms of up till 2n, sorry. So 2n minus 2, 2n minus 4, these are all even terms. 2n minus 1, 2n minus 3, 2n minus 5, these are all odd terms. So 2n minus 1, 2n minus 3, the multiplication of all the odd terms up till 2n multiplied by 2 power n. You can pause the video if you'd like. So, but the solution is 2n factorial is 2n into 2n minus 1 into 2n minus 2, 2n minus 3, 2n minus 4, all the way up till 1, divided by n factorial. Divided by n into n minus 1 into n minus 2, n minus 3, multiplied till 1. Right, so I can write this as 2 into n into 2 into n minus 1 into 2 into n minus 2 into 2 into n minus 3. So what I've done is, I've, for all the even terms in 2n factorial, that is 2n, 2n minus 2, 2n minus 4, 2n minus 6, and 2n minus 8, and so on, I take the 2 out of the bracket, and then this is what I get: 2 into n into 2 into 2, 2 into n minus 1 into 2 n minus 2, 2 n minus 3. You can imagine the next will be 2 n minus 4, so on, right? All the way up till 2, basically 2 into 1, into all of the odd terms of the equation or the expression: 2n minus 1, 2n minus 3, all the way up till 1, divided by n factorial, instead of expanding the whole expression. So if you see, 2 has been multiplied n times, right? Because there's a total of 2n numbers up till 2n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up till 2n. Those are 2n numbers, which means that there are n odd numbers and n even numbers. And so these are all the even terms, right? 2n, 2n minus 1, 2n minus 2. There are n of these even terms, which means that this 2 will appear n times. So 2 multiplied n times, this is 2 power n into n, n minus 1, n minus 2, up till 1, which is just n factorial. So these terms cancel, into 2n minus 1, 2n minus 3, 5, 3, 1. And this is what we get. This is the RHS of the equation. Okay. And one final question on factorials. So these questions will give a sense of how to work with factorials, how to do some basic algebraic manipulations of factorials, and this will help us to move on with the most important topic of the chapter, that is actually how to find the number of permutations and combinations. So thank you for watching this lecture.